Greetings, Math 111Z students, and welcome to Week 2 lecture notes. The first topic we're going to talk about today is interval notation. By the end of this section, you'll be able to use interval notation, and we'll even talk a little bit about set builder notation. All right, let's go ahead and get started. All right, let's review a few definitions from last week. Let's remember that the domain is the set of all possible inputs. The input variables are also called the independent variable. So that's easy to remember because input and independent variable. All the inputs are going to be on the horizontal axis of the graph, so left to right, or also the top row of a table. I'm going to write that down also. Also the top row of a table, top row or first column of a table. The range is the set of all possible outputs. The output variables are also called the dependent variable. They're going to be found on the vertical axis. They'll be on the bottom row or the second column, depending on the orientation of the table. And that's how to find those. Another way to represent a function, what did I push? And we won't use this a ton, is this function machine notation here. But it's sort of the idea of is we have this in the domain as all of our inputs. They're over here. They go through this function machine, which is language you might hear here and there, does something to it, and it puts out this output that is the range. So looking at this picture, let's look at the domain. Let's write it as a set to review our set building skills. So in the domain are three values, A, B, and C. So we would write domain equals the set A, B, C. And remember with sets, you don't have to put them in any particular order. So if we wanted to, we could write this as the set C, A, B. It doesn't matter as long as we have those three values in there. I generally put them in alphabetical order just to be organized. And the range for this example would be the set XYZ. All right, so let's look at an example of this as well. I'm trying to move my screen up. There we go. Okay, so if we have, again, a set representation of a function, here is our set of values. This means it takes 1 to 3, and it's just like if you're graphing, you graph the point x equals 1, y equals 3. It takes the input of 2 to the output of 4, etc., etc. So let's see if we can write down the domain. So the domain is going to be the set of all inputs. So that's 1, 2, 3, 5, and 0. So I'm just going to write 1, 3, it doesn't matter, 2, 5, and 0. Remember, order didn't matter, so I could put those in any order, and I accidentally wrote a 3 first, so there we go. As long as we have 1, 3, 2, 5, 0, as long as we have all these first values in the set, it's the set of the domain. And what is my range? Well, these are the output values, so I have 3, I have 4 again, I have 7, and I have 0. Let's take a moment. Is it okay that we have a double value in the range? Can we have 4 twice? Is it still a function? Yes, it is, because remember, every input has to have a unique output. We can repeat outputs for different inputs, but every time we have a 2, we get a 4. Like there's no conflict there. We don't have two different inputs, or two different outputs for the same input. That's what we really want to avoid. So going back, let's think about our range. So our range is going to be all those output values. So we have a 3, we have a 4. We don't need to write 4 again because 4 is already in this set. We have 7 and we have 0. So it's a little bit of a review on domain and range and sets. Let's start talking about interval notation. Let's suppose we have a function, and in the function, the domain is all numbers, all numbers greater than or equal to 5. Greater than or equal to 5. So how would we represent this as an inequality? We would just say x is greater than or equal to 5. All right? So writing that as an inequality. How would we represent that on a number line? Well, we want to include any number that is 5 or bigger. So we're going to go to 5, and we're going to put a closed circle around 5, so a closed dot, and that means we want 5 to be included in the domain. And then we're going to color everything to the right to indicate everything that is colored in is in our domain, starting at 5 and going on forever. So how do we write this in interval notation? So interval notation always goes smallest to largest. So you write your smallest number first and your largest number second. So our smallest number is 5, and we go all the way to infinity, right? So 5 to infinity. We're going to use a square bracket for the 5 because it's greater than or equal to, and we want to include that number in our domain. So we use a square bracket to indicate that we're going to include that number in our domain. And we're going to use a parentheses on the infinity. And we just do that for an agreement that all the mathematicians decided on. You can't ever get to infinity, so we don't want to necessarily include it. I'm not going to take off points if you put a square bracket around infinity, but it's just not, super cool. Let's go to, like other math is super cool. Let's go to the next problem. All right, we just did that one together. I'm having trouble with my spacing here. Let's go to the next problem. I would like you guys to take a moment to right now. We just did an example of this. I want you to try this example 3. Let's try representing a domain with interval notation. So go through this example, write the inequality, graph it on a number line, and write it in interval notation. Then we'll go over it together. Okay, did you pause the video and ready to come back? All right, let's go. Let's write the inequality. So we want a domain with all numbers less than -2. So we want x less than -2. All right, so let's graph that on the number line. We're going to use an open circle around -2 because -2 is not part of the domain. You have to be less than -2. And then we're going to color all the numbers to the left, all the numbers that are less than -2. Okay? And let's write it in interval notation. So I like to think about looking at my number line. Here's -infinity. I start there. That's my smallest number. And I go up to -2. So my interval is -infinity up to -2. All right, so here's a few important things to remember about interval notation. I'm not sure what I'm doing to make that happen, but it's annoying. Okay, so intervals are always going to be smallest to largest, or if you're reading it on the number line, left to right on the number line. Parentheses are going to be used to show that an endpoint is not part of the set or not part of the domain, and brackets are going to be used to show that an endpoint is. So let's fill out this little table. If we have a less than, we're going to have the less than symbol. We're going to use an open circle around the number, and we're going to use parentheses. If we have greater than, same thing. Greater than symbol, we're going to use an open circle, and we're going to use parentheses. If we have brackets, less than or equal to, we're going to use less than or equal to. We're going to use a closed circle, and we're going to use one of the brackets, depending on how the inequality is set up. Greater than or equal to, we're going to use a closed circle, and we're going to use brackets. So these should have or written in here, depending on how the interval is set up. All right, let's keep going. Let's talk a little bit about set builder notation. Set builder notation isn't as commonly used as interval notation, but it is something that is easy to learn and something that you should know how to do. So let's go through an example, and I'll show you how to use set builder notation. So let's suppose you had a function with a domain of all numbers between 5 and 10. Oops. All numbers between 5 and 10 inclusive on the number line. Inclusive means including them, so we're going to do square brackets. But let's think about the inequality. All numbers between 5 and 10. So 5 is less than or equal to x because it's inclusive, which is less than or equal to 10. If we didn't want the 5 and 10 to be included, we would use the word exclusive, so excluding them. All right, let's graph this on the number line. So 5 to 10 and everything in between. All right, let's write this using interval notation. We now have that skill. So we're going to go left bracket 5 because that's our smallest number, up to 10, right bracket because that's our biggest number. And then we're going to use set builder notation. And so we're going to say the domain equals, and we're just going to write the set of all x such that, and I know that's a lot of words, but really it's just the set of all x such that, that's what this little line means. And then we just put our inequality in here. We're going to go all x such that 5 is less than or x is less than or equal to 10. So really, with set builder notation, you've already done most of the work because you already wrote it in interval notation here, and that goes in the second part of the set. So just left set bracket x bar, the interval in the set. All right, and here's a little table for you guys. This is useful if you're making a note card for the first test and it's never too soon to start thinking about that. You might consider thinking about this table or actually just printing out this page and keeping it as a reference, because it just goes through all the examples of inequality notation for several examples, the set builder notation for several examples, and then what the interval notation is. And this pretty much covers all the possible ways that all the possible scenarios. All right, that's it for this video.